copper. So what is the reducing agent in the self-reduction reaction? What is the reducing agent which, in this reaction, what is the reducing agent?
Copper is
How do you define a reducing agent? Tell me. A reducing agent reduces a partner and gets its oxidized, isn't it?
yes.
Do you agree with me?
Yes.
Okay. Now you tell me, which is getting oxidized? Copper is getting reduced. +1 is 0. How do you say Q plus is reducing? Is acting as a reducing agent? Copper is getting reduced from +1 to metal 0. Which is getting oxidized? Sulfide ion.
Yes.
What is the electron change? What is the oxidation state of sulfur? So what is the electron change? That is why you get 6 moles of copper.
Yes.
Sulfide 2 minus goes to sulfur dioxide 4 plus. So it's a 6 electron change. And copper, 6 copper plus 6 electron will give you 6 copper. So don't never ever say that Q plus sulfide is a reducing agent. Because copper is getting reduced. It is the sulfide ion which acts as a reducing agent, which reduces copper plus to copper and gets oxidized to sulfur dioxide. This question I ask everybody, and everybody gives me the wrong answer. So now, what you got now is the blister copper, that copper with a blistery appearance. Because why the blistery appearance? Because sulfur dioxide evolved from the molten copper. Blister copper contains about 98 to 99% copper. And this is further purified by electrolysis, electrolytic purification method. Where you take about 15% copper sulfate solution, dilute sulfuric acid as the electrolyte. Impure copper as anode, pure copper as cathode, and this is the electrolyte.
Yes.
I have already told you, explained to you why sulfuric acid is used.
Yes.
To enhance the conductivity and to prevent the hydrolysis. So what happens? When you do the electrolysis, the iron, zinc, nickel, cadmium, they get oxidized and dissolved into the solution. Whereas the less electropositive metal like silver, gold, lead, they fall off from the anode as a anode mud and sink at the bottom. And the copper at the anode gets oxidized to copper 2 plus. So impure copper gets oxidized to copper 2 plus and releases 2 electrons, and copper sulfate, the copper 2 plus from copper sulfate accept the 2 electrons and get reduced to pure copper, which is deposited at the cathode. That is what is being done to prepare copper in a pure state. Okay?
Yes.
Now write down some of the alloys of copper. It's a very useful alloy. The constant 10 is very useful because it is used in making resistance box. Because this alloy does not change its resistance over a wide range of temperature. HF and fluorine, hydrofluoric acid and fluorine, they are highly corrosive substances. They react with almost all the metals. So it was a difficult thing to find a suitable container for fluorine or HF. But monel metal is used as a container for HF and fluorine. That is why monel metal is so important.
Sir, doesn't this alloy corrode by the action of HF and fluorine?
What do you say?
Sir, doesn't this alloy corrode by the action of HF and fluorine?
Tell me again.
Sir, doesn't this alloy corrode by the action of HF and fluorine?
Copper reacts with fluorine to form copper fluoride, which forms an upper layer on the of the monel metal. And this is not soluble in HF or fluorine, so it protects the inner metallic layer. So it forms an insoluble cupric fluoride on the top and protects the inner layer. That is why it is used. It reacts, but only the top portion. The lower portion is not attacked.
Yes.
Copper sulfate pentahydride is known as blue vitriol. There are 4 vitriols are there.
Yes. Green. White.
And what is the 4th one? What is the 4th one? Sulfuric acid is oil of vitriol. The first method, where copper is heated with concentrated sulfuric acid. Concentrated sulfuric acid has 3 functions. Concentrated sulfuric acid is a strong acid Hot concentrated sulfuric acid is an oxidizing acid and it is a dehydrating acid. It removes a molecule of water. So, concentrated sulfuric acid plays three different roles. So, here, concentrated sulfuric acid acting as a oxidizing agent. So, it oxidizes copper 0 to copper 2 plus.
Yes.
And sulfuric acid gets reduced to sulfur dioxide. Now 0 to 2 is a 2 electron change.
Yes.
And 6 to 4 is also 2 electron change. Then the mole ratio should be 1:1.
Yes.
Because the number of electron change has to be equal. That represents the number of moles. But I have written 2 moles of sulfuric acid. Why? Because the sulfate ion will come from where? Copper 2 plus has to be associated with the sulfate ion. Who will provide the sulfate ion? One mole of sulfuric acid gets reduced to sulfur dioxide. Another mole of sulfuric acid provides the sulfate ion to copper 2 plus. So it forms copper sulfate, sulfur dioxide plus 2 moles of water.
Yes. Yes.
Dilute sulfuric acid is not an oxidizing agent. It is simply an acid. So I need an external oxidizing agent. And so the oxygen So oxygen is acting as an oxidizing agent. When oxygen acts as an oxidizing agent, it gets reduced to oxide ion.
Yes.
So 1 mole of oxygen will give me 2 oxide ions. What is the charge on the 2 oxide ions? 4 negative charge.
Yes.
4 negative charge.
Yes.
4 negative charge involves 4 electrons. Oxygen accepts 4 electrons to convert into oxide ion.
Oxide ion.
Copper goes to copper 2 plus, releases 2 electrons. Oxygen requires 4 electrons. So I have to multiply by 2.
Yes.
So 2 copper gives 2 copper 2 plus 4 electrons.
Yes.
That is why I have written 2 copper per mole of oxygen.
Yes.
So 1 mole of oxygen will oxidize 2 moles of copper to form 2 copper 2 plus ion. So I need 2 moles of sulfuric acid to form 2 moles of copper sulfate. For 1 mole of copper 2 plus, 1 mole of sulfuric acid is required. For 2 moles of copper 2 plus, I require 2 moles of sulfuric acid. So it forms 2 copper sulfate and 4 hydrogen ions. When oxygen acts as an oxidizing agent, it gets reduced to oxide ion. Sulfuric acid ionizes to give you H plus and sulfate ion.
Yes.
Copper 2 plus combines with sulfate to form copper sulfate. And H plus combines with oxide ion to form water. Is it clear?
Yes.
The third method you can see that copper is plus 1 going to 0 and 2 plus.
Plus 2.
So what is the reaction called? So for disproportionation reaction you have to make 2 arrows. One upward, one downward. Copper plus to copper is, it accepts 1 electron to get copper.
Yes.
Copper and copper plus to copper 2 plus, it releases an electron.
Yes.
So in both cases, the number of electron acceptance and the release is the same. 1 is to 1. So 2 copper plus will give me 1 copper 2 plus.
Yes, sir.
So 2 copper gives me 1 copper 2 plus. And sulfuric acid provides the sulfate ion for copper 2 plus to form copper sulfate. And 2H plus combines with the oxide ion to form water.
Yes.
Is it clear?
Yes.
Now copper sulfate, when you crystallize out from water, you get copper sulfate pentahydrate. Can see that as the number of water molecule decreases, the intensity of the color decreases. Blue becomes light blue, pale blue, and ultimately becomes white. So, anhydrous copper sulfate can be used to detect the presence of water. If there is water present, suppose I have a benzene. I do not know whether the benzene contains water or not. I add anhydrous copper sulfate. If the anhydrous copper sulfate turns blue, that means the water is present in benzene.
Yes.
For carbon tetrachloride, I do not know whether water is present. I add anhydrous copper sulfate, if it turns blue, that indicates the presence of water. So, anhydrous copper sulfate can be used to detect the presence of water. Because the water will turn anhydrous copper sulfate white to blue in color.
Excuse me, sir. So why the color changes?
The color changes because as the number of water molecules from the coordination sphere decreases, the separation decreases. So the coordination number changes. So the lowering of coordination number lowers the separation, and now they say lower the separation, it does not require visible light, so it falls in the infrared light. So it becomes white when it is anhydrous, and as the number of water molecules decreases, the gap decreases, and the amount of visible light required for electron excitation decreases, and so the intensity decreases.
Yes.
Yes.
Copper fluoride exists, cupric chloride exists, cupric bromide exists, but not cupric iodide. This was a question which I asked in one of the JE, in 1 year in JE, that why cupric iodide does not exist. And the reason is the first reaction. That iodide reduces copper 2 to copper 1 and gets oxidized to iodine. So cupric iodide does not exist. But fluoride or chloride or bromide, they cannot reduce copper 2 to copper 1. So they are weaker reducing agent. So copper chloride exists, copper bromide exists, copper fluoride exists. But iodide is the strongest reducing agent among the halide ions. So it reduces copper 2 plus to copper 1 and gets oxidized to iodine. As a result, cupric iodide does not exist.
Yes.
Same reaction you can see here. That instead of potassium iodide, if I add potassium cyanide, I get copper 2 plus gets reduced to copper plus. And cyanide ion goes to cyanogen. Iodide gives you iodine, cyanide gives you cyanogen gas. So iodide and cyanide, they are behaving very similarly. So iodide is very similar to cyanide. So cyanide ion, azide ion, thiocyanate ion, they are called pseudo halides. And cyanogen this I have written already here, cyanogen. So cyanogen and thiocyanate, they behave like halogen. So they are called pseudo-halogens. They are not halogens, but their reactions, they give similar reactions like halogen. So they are called pseudo-halogen. Cyanide, azide, and thiocyanate. They are not halides, but they give a chemical reaction similar to halide, so they are called pseudo-halide.
Yes.
They behave like halide, but they are not actually halide, so they are called pseudo-halides. Copper sulfate aqueous solution when I add ammonium hydroxide. If I take copper sulfate solution, aqueous solution of copper sulfate, which is blue in color, if I add ammonium hydroxide drop-wise, I get almost a so light blue.
Sir, we cannot. Sir,
Voice is not.
sir, we are not able to hear you clearly. We are not able to hear you.
Why?
Yes, sir, now.
Sir, some disturbance. Sir, please repeat your
Sir,
last.
please repeat your last statement.
I said that if you take copper sulfate aqueous solution of copper sulfate, which is blue in color, if I add ammonium hydroxide, I get a very pale blue precipitate, almost white copper hydroxide. When copper hydroxide is added, ammonium hydroxide in excess, when you add excess of ammonium hydroxide, you get a deep blue color that is tetramine copper 2 sulfate.
Yes.
And this is known as this reagent is used for preparing artificial cells. No other metal will give this reaction. If you get a green or the blue salt, if it is soluble in water or HCl, if you add excess ammonia, if you get a deep blue color, you close your eyes and write copper 2 plus. Because no other metal ion will give deep blue color in excess of ammonium hydroxide. Only copper gives. And this copper, due to the formation of amine complex. And this amine complex is known as Schweitzer reagent, which is used to prepare artificial cells. If you add copper sulfur dioxide to copper sulfate, the sulfur dioxide reduces copper 2 plus to copper 1 plus and combines with the thiocyanate ion to form a Q plus thiocyanate, a white precipitate. And it forms potassium sulfate sulfuric acid and cuprous thiazide. So the copper sulfate can be quantitatively precipitated as cuprous thiocyanate by action of sulfur dioxide in presence of potassium thiazide. Copper sulfate, when you add potassium ferrocyanide, in the IUPAC nomenclature, I have written the conventional name of potassium ferrocyanide.
Yes.
It is not hexacyanoferrate. I have written as potassium ferrocyanide.
Excuse me, sir.
Bolo?
So in this reaction, as the reactant CuSO4 positive is in a stabler oxidation state. So without a rise in temperature or heating, how can SO2 probably oxidize it to Cu positive?
Where is the positive? Copper 2 is going to copper 1. Is it an oxidation? Or a
No,
reduction?
sir. Sorry, sir. That will not be done because Cu positive is in a stabler oxidation state. So unless a rising temperature is mentioned,
No,
the
no.
reduction.
No, you don't need because sulfur dioxide is a strong reducing agent. Why copper 2 plus gets reduced to copper plus in presence of potassium iodide, in presence of potassium cyanide? Why you get cuprous cyanide? CuCN? Why you get Cu2I2? Where copper is plus 1? So there are reagents which can reduce copper 2 to copper 1. In presence of a reducing agent, copper 2 can be reduced to copper 1. Like iodide, cyanide, sulfur dioxide, they can reduce copper 2 to copper 1. Despite the fact that copper 2 is the most stable oxidation state. That is in absence of a reducing agent. In presence of a reducing agent, it can be reduced. Okay?
Yes. Yes.
And this is a very characteristic case for copper. To detect copper ion, if I add potassium ferrocyanide, I get a brown precipitate which no other metal ion will give with potassium ferrocyanide. Only copper will give a precipitate with ferrocyanide to copper ferrocyanide. And this is a characteristic case for copper 2 plus.
Sir, in these reactions, yes, sir.
Quick.
Sir, in these reactions, we are using that white CuSO4 or means with the water of crystallizations we are using
Aqueous
CuSO4.
solution of copper sulfate.
In all the reactions. Okay, sir.
Okay, that's all for today's lecture, alright? So,
Yes, sir.